Good morning, Fancy Meat Computers! Welcome once again to your favorite class in your favorite semester of your favorite degree. I see that the chat is split three-way tie between Happy Face, Emotionless Face, and Fish. So there we go. Ah! Emotions have pulled ahead of Fish. We shall see how this turns out over the course of people coming. Ah! There we go. Someone's unhappy. Nice to see someone unhappy this morning. A while the professor feels. Yeah. That's my Pokemon impression for it. Except I always get left and right mixed up. Yeah. It's supposed to be a fish. Yeah. You can see the fish, right? Now that you know it's a fish, you can see how I got fish. A cryptid emotion. Yeah. No. Unfortunately. Oh, heck. Conversations. Let's have conversations about type conversions. Ho ho. That's a pun. Do we have any announcements? Assignment 3 has been released. So yes, Assignment 3 has been released, so you should be able to download and perform Assignment 3. Yes. Recommend doing it before the test. Just putting that out there. So. Okay, alright. Well, we've got a lot of ground to cover. A lot of ground to make up, actually. So I think I'm just going to power on through topic 7. So here we go. Hold on to your butts, because this is going to be a wild ride. Not really. This is, of all of the topics in this course, I consider topic 7 to be the biggest yawn burger with a side of snores. But, you know, we have to do it anyway. It's very important information, even if it isn't that interesting. So, we have to do it. It'll be particularly useful for assignment 4. So, converting string to double. The C standard library, stdlib.h, defines str2d, which converts decimal numbers to double precision floating point numbers, or doubles. So, we've got this new... This is basically what this entire this entire topic is going to be from this point forward, is like me explaining various library methods to you, or library functions to you. So, str2d takes a constant character array string and a character or a double pointer end pointer. String is a pointer to the string to be converted. Leading white space is ignored. String2d converts as much of the string as it can to double format and then returns that double. End pointer is the address where string2d stores the address of the character that it stopped on. So this end pointer is an implicit return value of the function. Yeah. This is an example of a function using pointers to, in effect, return 2 values. Y'all remember when we used cube by reference to return a value using a pointer, right? Well, this is why this is a double pointer, right? You need a memory address of a character pointer because we're going to change that character pointer to whatever character we stopped at during this conversion process. There we go. So, I think that in this case we can risk doing an example. I don't need a new folder. What am I? Well, all right. Topic 7. Get it? Topic 7.c. There we go. So, include stdio.h and include stdlib.h. So is the double pointer giving the address to a pointer to know the address of that pointer that points to the address of the converted double string that is now a double? Let me read that again. Is the double pointer giving the address to a pointer in order to know the address of that pointer that points to the address of the converted string that is now a double? No, it's you give it a blank one, and then it fills it up with whatever you stopped at. So this is kind of like another language would give you the index of the element that it stopped at, but here, because this is C, you get a pointer to the element that it stopped at. It's too early for this. It's too early in the morning. While I agree, I am getting paid to do this, so I'm going to do it. It does sound like a riddle. Very much it sounds like a riddle. Int main void. If we have a constant character array string pointer string, say 51.2% of people, and then a char star string pointer, we can say double D is equal to str2d string, and then the address of string pointer. So basically we're using this in exactly the same manner that scanf uses a variable's address. It requires an address, but you don't declare a pointer for it. You just essentially give it the memory address of an existing variable. So, yeah. Good. So, print f the string s is converted to D. So we put string in there and also D. We then say printf blah printf the address of the string is key string. I hope this works. And printf the address of the first unprocessed character is p, and that should, in theory, be string pointer. So let's load this bad boy up. GCC. Ah, I've got syntax errors. There we go. Oh, I'm converting it to a... Yes, it should be an F for float. Expected. Did I forget a semicolon? I did forget a semicolon. So this is a good hint, right? You'll notice that I fixed this one semicolon error, and it got rid of two compiler errors. One which was completely unrelated to the, the only reason that this error was an error is because this line didn't work, right? So when you're fixing bugs in C programs, the preferred method is always to start with the first bugs that you get and move down through the list. Why is it a double pointer, though, not just a regular pointer? Because it's already a regular pointer. The address of a pointer is a double pointer, right? So, let's execute this bad boy. I forgot to include new lines. Doop-a-doop-a-doop. Doop-a-doop-a-doop. Fixes a bug. 3 more pop up. That's live. So, I gotta recompile. There we go. So, you will see that the string, so that's the string, is converted to 51.2, which is correct. The default is to print floats to 6 decimal places of precision. The address of the string is this pointer. The address of the first unprocessed character is this bad boy, and you can see that, pardon me, this is a little bit further on in the same character array. There you go. And just for fun, and is character, and then let's just dereference this thing. String pointer dereference. Let's execute, and is %sign, which is correct. The first unprocessed character is %sign. So there we go. Ta-da! String conversion. So that's what we mean when we say implicit return value, right? Although we, we are calling this function, right? And normally we think of functions as having one return value, but essentially we're using pointers to pass a character pointer by reference to it, so that the function can place any particular information it deems relevant into the things that you pass to it. And then you just get it without having to worry about returning it. I see fish eventually won. So there we go. Any questions? Hopefully not. I'm not going to be able to demonstrate all of these, but we'll do occasional ones that are interesting, relevant, or pertinent. So that was conversion to a double. Let's talk about conversion to an integer. Similarly to string to D, standard library provides a function for converting strings to integers, str to L. That's an L and not an I. That's an important difference. So this actually returns a... for next poll, could I include antifish? I'm not sure what antifish would look like. Would that be a bird? Is a bird an antifish? So if it stops at characters, if we were to put a double in the middle of the string, would str2d not work? Correct. Let's try it out and see, shall we? Blah, blah, blah. So we've got we've got it in the middle here, right? So if we compile that, process it, you'll notice that the first unprocessed character is in fact the first character of the string, right? And you'll notice that the pointer that it returns is the same pointer as the string itself. So basically it says I couldn't do anything, and that it picks out 0, right? So that's what it does. So one of the implicit requirements of string to D, and this is true of all of the conversion methods, is that whatever the first pointer is, it needs to point to the first character of the thing you're trying to convert within the string. So the way to fix that would be, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. All right, let's see. If we add 17 to this, add 16 just to be on the safe side. Let's see if this works. Yeah, that works. So you can offset the pointer by however deep the thing is if you want. Another way, of course, to be able to do this is to loop through the string looking for the first occurrence of a numeric character and then use that. That's another way of doing it. But yeah, invert all the characters used to create fish for antifish. Oh. It's a theoretical mathematical constant for one ODE we did in... It's been a running joke ever since. Oh. Okay. Yeah. So that's a good point. I'm glad that we brought that up. So string to L produces a long integer. The return type of this guy is, of course, long int, which is 8 bits. Sorry, 8 bytes. String to L accepts a third argument, the base of the number we are interpreting. So if it's 0, that means octal, decimal, or hexadecimal. 2 to 32 is whatever base is indicated, and bases higher than 10 use alphabetic characters in the same way as you would do hexadecimal numbers. So there you go. There are a number of functions that work in a similar manner. It's a running joke and not a swimming joke because it is an anti-fish and not a fish. Okay. So anti-fish would be something like that. So we've got conversion methods for doubles, floats, long ints, unsigned long ints, long ints, and unsigned long ints. You may notice that we do not have conversion functions for integers and short integers. This is because this is possibly directly... so this is possible. It's possible to perform conversion straight to an integer if you use the a to I function. However, this is considered an unsafe function. It's unnecessary, as string to L can be easily typecast as either an integer or a short. I forget what about it is, like, not safe, but they recommend you don't use a to I. Use string to L instead. So, to understand why there's no string to I in the C standard library, we need some historical context. Oh, I forgot this. These slides are in here. This is actually interesting. This is about the history of the development of the language. So, back in the year of our Lord 1972, for 16-bit architectures was C created. The original integers were also 16 bits. However, shortly thereafter, 32-bit file systems became popular because you can store more with a 32-bit file system. You can do things like store floating point numbers in one word rather than split across 2 words. At first, programmers used int arrays of size 2 in order to bridge the gap. So basically what happened here, the word size of file systems outstripped the word size of processors for a brief moment in time. That is to say, the hard disk was operating in with a 32-bit word size, whereas the processor itself was still stuck in 16 bits. So you needed at least 2 CPU processing cycles in order to calculate any one piece of hardware or hard drive memory. So that was kind of a strange thing. Programmers at that point were using integer arrays of size 2 in order to sort of fix this, fill the gap, while we were waiting for better processors to come along. So long was added as a native data type to C, despite needing multiple 16-bit CPU operations to simulate 32-bit arithmetic. So this is what happened during the early years of C development. Is these guys at Bell Labs, they would write their compiler, they would look at how people were using C, and then they would say, you know what, this is a terrible kludge. Let's do a in the next C standard that we're releasing, 2 months from now, let's fix that so that they no longer have to worry about using an integer array, and they can just have a native data type that has a 32-bit integer. So they invented, that's where long comes from. Programmers realized that they could increase efficiency by using int, where they could get away with it, and long only if they needed the extra bit width. So essentially, now that there were two natively supported integer sizes in C, and therefore in the Unix operating system, because the two things were basically the same thing for a period of time, programmers realized that you could actually improve efficiency by using a smaller integer, because the smaller integer actually matched the word size of the CPU rather than requiring multiple CPU clock cycles to execute like anything you would do with long integers. So people were using integer. This prompted the addition of short, originally and still defined as 16 bits. So they saw that people were using arrays to kludge their way around needing a longer integer than they currently had. Then they noticed people were using the shorter one for for efficiency. So they were like, well, we don't want int to be the one that's efficient and long to be the one where you need it. We want int to be the one you use in like the general case, and we can have a special exception for both needing more bits and a special exception for needing more speed. So they developed short, the short integer, which is the performance-focused integer. Basically, they were trying to free integer up to mean something convenient for performance. So essentially that, So even by 1976, the code base of C had become so large that changing the definitions of short, int, and long was considered highly irresponsible. So you have to kind of understand what was going on with computing at this time. This was the development of the so-called microcomputer. This explosion in computing and computer hardware was driven by the widespread basically what had happened is you had two parallel hardware paradigms that had been developing through computer history. And you mechatronics students should be particularly interested in this because you still use, when you get out into industry and work on big machines and stuff, you'll find that a certain number of these things are still kicking around in industry. So the old way of doing computing was with vacuum tubes and relays. Relays are still very highly used in industry because they are suitable for switching high-power applications, something that you would instantly burn out any solid-state electronics, right? So you had a development curve for sort of vacuum tube-based computers, so they were advancing at a particular rate. And then you have this brand new technology, solid-state computing. Initially, it starts off worse than vacuum tube technology, but just because it's so much better at what it does than vacuum tubes, because it requires so much less power and you can miniaturize it, by the time you hit about the late 60s, you reach solid state reaches parity with vacuum tube, and then it just blows past it like it's standing still on the highway. So by the time you hit the early 70s, mid 70s, you have the development of the so-called microcomputer. And the original microcomputers were they were not what we would consider to be a microcomputer these days. There is more electronics going on in this remote control than there was in, like, the PDP-7, for example. So, basically, you didn't need a whole room for a computer anymore. This made them much, much, much cheaper. So, because they became cheap, at least relative to, the ENIAC or the UNIVAC, those types of computers, which are like whole room computers, you didn't get like one computer per university anymore. You got like, one computer per laboratory, which, was much, much better. It went from like hundreds of thousands of dollars investment to like maybe a few tens of thousands of dollars investment. And of course, as the price drops, they become more and more popular. But essentially, because of this explosion of the hardware, you had also simultaneously a widespread adoption of the latest, the newest and fanciest programming language that ran on the newest and fanciest operating system, which at the time was Unix and C. So, essentially, C came to dominate the programming language the market share of C relative to, Fortran? Blech. Relative to Fortran or BASIC or Pascal or COBOL or any of the other languages that were going on at the time, C just, within a couple of years, completely annihilated all of its competition. And that's why most languages that you will use these days are C-based and not Fortran or Pascal-based. Although, people still have some affection in their hearts for things like Fortran and Pascal. But, so yeah, C completely dominated everything. So only, within half a decade of C originally being released, there was so much written in C that the focus had to shift from, doing interesting, innovative things with C and maintaining the existing code base. This is why, in C, you must maintain the property of back compatibility, because much of the code base that they wrote in the 1970s is still being used. It's these programs are still being executed today. So if it would be a bad thing if, sections of the Unix kernel were no longer compilable because GCC updated to the point where it invalidated some old C programs. But yeah, so that's interesting because C is a language that's had to grow and change as the architectures on which it has the architectures have changed, right? So once we advanced from 16-bit CPUs to 32-bit CPUs, int and long became the same size. So long stayed where it was, but integer expanded itself to 32-bit because it no longer needed to be restricted to 16 bits for performance, right? With a native 32-bit architecture, you can perform 32-bit math in one clock cycle, so 32-bit becomes the new fast, right? Whereas short still remained where it was. Primarily for, the reason we kept short where it was is primarily for, memory storage, right? Didn't I show a graph of code popularity over time early on showing that C is the best language? Yeah, that's the TIOBE index. TIOBE. I don't think it's because it's popular because it's used so much as it's popular because it's learned. TIOBE index. Yes. Just show me the graph. There we go. So let's see where the TIOBE index is right now. Uh-oh. Here we go. As of October of this year. Come on. There we go. Java is now under C. C has been pretty strong, but it's taken a dip recently. Who's this guy? This is Python. Oh, friggin' Python, man. That's not it, though. What's this little purple guy? Visual Basic? Oh, come on! Oh, that just makes me mad. Visual Basic. Frig me. Cobal's still hanging on at 23rd place. Visual Basic. Give me strength. Oh, has Python overtaken C now? Ugh. Dark days ahead. Dark days, my friend. Dark days. Yeah, so the way that the TIOBE index works is that they're basically doing the way that they measure that is the number of people performing Google searches for how to do X in, like, Y language. They skim off Y language, and they generate their index from it. So it's not necessarily what's being used in industry, but it's what people are learning in school, primarily. So to some extent, it's like, you know, you're learning it in school because you're learning it in school, you know? But yeah, friggin' Python, man. Snake language. I'm going to call it snake language from now on. Anyway, so we're now under 64-bit architecture, as I'm sure all of you are aware. So long was increased to 64 bits, but int remained at 32 bits. In practice, integer values rarely exceed 32 bits, so memory considerations became the performance bottleneck. Rather than processor, so the thing that would be bottlenecking it now is like hard drive storage rather than processor architecture. So that's why they kept int at 32 bits, because you can store more of them, and you can store twice as many ints as you can long ints, right? In short, for string to L, long int did the job and is easily castable to int, so nobody thought string to I was necessary. So that's the reason. So at the time that a lot of these standard libraries were being developed for 32-bit architectures, int and long were actually the same size anyways, so it didn't matter. So there we go. Long, that was a bit of a long tangent, but I really like that story, you know? Someday, a better language will come along, and Python will lose its crown. It really, it's terrible. It's terrible. I'm so disappointed. I'm especially disappointed in how popular Visual Basic is becoming again. Because that means, like, the only use case for Visual Basic is if you're doing, like, Excel scripting. You know? Which means Microsoft is winning. Damn it! Ah! Alright. So, converting things to strings. Now that we know how to read numeric values from strings, the question remains, how do we write numeric values into strings? Trick question. We've been doing this the whole time. So we've been using printf, right? Printf does this function exactly, however, it dumps everything to standard output rather than a particular string that we have going on in our program. But we have snprintf, which writes to a specific memory address. So snprintf, I like to call it a cousin of printf. Basically, it just redirects whatever you would be putting in the console. It redirects it to a string. So, character, string, size, right? So basically, it's everything that you usually know about printf with two additional arguments up front, string and size. String is a pointer to the memory address the characters will be written to. Size sets the maximum number of characters to write. Remember to leave enough space for both the above, in both of the above for null termination. Every argument past the second is used precisely in the same manner as printf. So, the return value of SNPrintf is the size of the format string after substitution. Note that this may be distinct from the size of the string written into memory. This means that we can check to see if the string had to be truncated by comparing the input size to the output size. So, basically, SNPrintf is a safe version of SPrintf, which does not have the n, in which you do not have to specify the size. Because you have to specify the size, it's like the same thing as constraining your, when you use scanf, if you constrain the size of the string that you're writing to, then you can avoid stack smashing attacks. It's kind of the same idea, but you wouldn't be expecting, like, yourself, like, the left half of your brain to, like, put, you know, a stack smash attack into your code intentionally, you know? But at the same, so it's more like to protect you from your own stupidity. But yeah, so specifying the size, anything that exceeds the size is just truncated. So that's why it returns the number of characters it's written, because then you can compare how much it was supposed to write to how much it did write, so you can tell if it truncated anything or not. So yeah. Any questions about any of that? Any questions? Oh, I just got that. It's a running joke and not a swimming joke because it's an anti-fish and not a fish, because anti-fish presumably don't swim. I got it. What does the _t represent for size t? So size t is a data type that's defined in the standard library. I'm not sure why. It's basically equivalent to integer, but it's like it's being aliased as size t. Presumably that's size type. Whereas, so you can have size as just like a regular size, but this is like size type. I'm kind of lost on converting to strings. It's easy. It's easy, my friend. I will do it for you right now. So let's say char star output. Or let's not even do a char star. Let's do output 100. Just for fun. SNPrintf. Output, cap that at 100. Cap that at 99. The output is D. Then we put a new line character, like I always forget to, and then we can put the D that, well, that's a float, isn't it? There we go. All right. And then if we printf as a string the thing that we just converted, this should hopefully work. There we go. The output is 50 to 51.2. There you go. One of these days, I would love to hear your thoughts on Java. Java was a... Java is kind of going the way of the dodo. I think. I mean, people still seem like... Eclipse is still a popular thing among certain circles for reasons I can't fathom, because it's terrible, in my opinion. I hate Eclipse. I hate all of these Eclipse plugins. I went to I only went to one academic conference in my life, and it was basically Eclipse plugins, the conference, and I was like, come on, guys. Really? But, Java, I think, will eventually be completely superseded by the new guys, the new kids on the block, like, Rust and, some of the other ones. I'm not sure that there's anything that Java does, that's, distinct enough anymore for it to hold on to its market share. In order for a programming language to have market share, it needs to do something that other languages don't do. And I'm not sure that there's much that Java doesn't do, and there's not much that Java does that nobody else does anymore, because Java was so influential, right? And it didn't, basically Java will stick around because of its existing code base for a long time, but, yeah, I think probably there won't, increasingly active development will move to better languages, I think. Java was super innovative, it was super innovative for its time, but, because it was so successful, everything that was good and cool about it has been, slurped up by all the other guys. But, yeah. So if the value you put in is smaller than the size, once your input is done, it is implicitly, it'll implicitly use the null character. Yeah, it'll backfill with nulls. My dad taught me code in Java in Eclipse, so I feel personally attacked. No. I mean, how long ago was this, 5 years is a very long time in software, Unless it was, 3 days ago, I would say probably your dad should invest in, a faster and better programming language than Java, but Java is still applicable. Java is the, it's like the language preferred by 40 to 50-year-olds these days, Anyway. I'm not trying to diss Java. I think it's a really good language, I'm just saying, there are lots of excellent things that end up in the dustbin of history, and I feel like that's the direction Java is taking. If you even look at the TIOBE index, it's let's see this again. Steady downward trend since 20 years ago, But yeah. Steady downward trend for power yeah. Java has been power crept. Yes. That's a good way of putting it. It's like in Pokemon cards, where they keep releasing new Pokemon cards that are better than the old Pokemon cards, so, so that you have to keep buying the Pokemon cards, because, nobody in their right mind would take, the original Charizard to a tournament now, because he's so completely outclassed, despite the fact that at one time he was the most powerful card in the game. Java is for boomers is basically what I just said. Yeah. They're not boomers. Boomers are older than that. I'm talking about Gen Y. Wait, no, Gen X. Pardon me. I'm Gen Y. Because they think that, millennials... For a time, they called millennials Gen Y because it's, incremented Gen X. But no, it's, Java is the preferred language of Gen Xers. Actual boomers are the ones who are still banging on about Fortran and Pascal. And Lisp. But anyway. So let's talk about some other types of string functions while we still have some time in this class. String copy. So, have you ever wanted to copy a string? Well, string copy and string n copy are the functions for you. So you have two strings, string 1, string 2. This takes the string stored in string 2 and copies it into string 1. Simple as. String n copy is just a size-restricted and therefore slightly more safe version. So yeah, it's similar to the size argument in SNPrintf. String n copy will copy at most n characters. This guards against buffer overflow, making string n copy the safe version of string copy. Once again, you must make sure, 1, that S1 is large enough to contain S2, and 2, that n takes null termination into account. So you have to plan for null termination. That's just how it works. You friggin' Zoomers think everybody over the age of 23 is a boomer. Like, jeez. Friggin' Zoomers, man. You and your Zoomer humor. Nobody gets you except yourselves. I'm just saying it. So, we also have a few more. String cat, which is a string concatenation. So if you were wondering what your equivalent to the plus operator on strings in Python is, it's this guy, string concatenation. String cat uses, the usage is almost exactly the same as string copy. The null character terminating S1 is overwritten with the first character of S2, and it just concatenates them together. We don't get ourselves. Yeah, that's fair. Angry prof shaves fist at Python. Yeah. Yeah. Friggin' Python, man. Python! Gen Z is basically younger siblings of millennials. Yeah. Yeah. Okay. I'll just do the other two here on this slide. We'll finish off this slide and then we'll get out of here. So, string error. Accepts an error number, finds your computer/compiler's corresponding error message, and returns it. So that's kind of fun. And string length. Accepts a string and produces the number of characters in it, null character excluded. So you can see where, like, Python gets its len function's name from, right? Yeah, anyway. So there we go. That's our class. If you have any questions, please inform me of your question. I just laughed at a picture of a microwave. Not even I understand our humor. Yes, it's difficult. It's difficult, you know? Because, like, I really do think it's an exclusive club. It's like, I haven't quite mastered Zoomer humor, you know? Boomer humor is kind of easy. You don't even have to tell a joke. All you have to do is, like, play the wah wah trombone behind it, and, like, there you go. It's like, okay, so I have a young child. Like, he's a 6-month-old. Every once in a while, we watch The Gumby Show, right? Which is, there's a streaming service called Tubi, which I'm not endorsing. I'm just mentioning its existence. It's like Netflix, but it plays ads and is free, and it has basically all the boomer TV shows. So I kind of like it because I kind of like old television because, you know, anything past like the year 2002 that was made in terms of television just makes my soul hurt. So anyway, so we watched The Gumby Show on Tubi, which is basically like, if you've never seen The Gumby Show, it's like 5-minute cartoons of stop-motion animated, like, plasticine guys who are, like, if you've ever seen Gumby, he's just a lump of green plasticine with a swoop on the one side. But anyway, they always, like, because this is the era it comes from, they always, like, end any particular episode of The Gumby Show with the worst joke you can possibly imagine. Most of the time, it's like, it doesn't even register as a joke. You only know that they think they were telling a joke from the context of it being at the end of the episode and all of the characters on the Gumby show laughing at it. It doesn't even move the needle. Yeah. Yeah, I like, terrible jokes aside, I actually really like the Gumby show. I think it's, like, a top-shelf children's entertainment, to be honest with you. But yeah, eh. Actually, going back to that power creep metaphor, in the base set meta, Charizard isn't even that strong. Blastoise, Rain Dance, Dex, Haymaker, and Stall define the meta. Yeah, I know. But, you know, if you want, like, it was the card with the single most powerful attack, right? So that's got to be worth something. And yeah, I know, it's like its ability cripples its actual use, because you can only use it every other turn. And 120 hit points isn't that much when you can, you know, when you can only attack every other turn, especially if you get, like, paralyzed looped. But, like, a Squirtle could easily take down a Charizard in that game. But, well, a lucky Squirtle could take down a Charizard in that game. It would have to be a very lucky Squirtle. But yeah, no, like doing 100 damage all at once will take out most people one shot. And that's why. But you may say that post 2002 TV is bad, but Doctor Who is, with the 9th, 10th, and especially 11th Doctors, were way better than the older ones. Oh yeah, no, I agree. And like, the exception, as always, is British TV. British TV is always good, relative to anything else that's going on. Yeah. Yeah. Yeah, I know Blastoise is better. Yeah. But yeah, so anyway, yeah, like, I'm trying to think of an example of, like, a joke they would do at the end of of an episode of Gumby. It was like... Yeah, I can't even think of it, but it's like... Just go watch an episode of it on YouTube and you'll know exactly what I mean. But yeah, it's, like... Oh boy. But yeah, like, boomer humor is, like... You just make, like, one very mild observation that something is not exactly in line with, like, the social structure of, like, the 1950s, and there you have a joke in boomer humor, right? With Gen X, it's primarily cynicism, right? Cynicism is the only funny thing to a Gen Xer. So that's how you get, like, comedians like Jerry Seinfeld and oh, what's his name that was in Groundhog Day. You've got like the snark sniper. That's like the characteristic Gen X humor guy. And I think that bleeds over into the millennials to a certain extent. And now, like, internet has just disrupted, like, I don't really think we can say that we have, like, a unified culture anymore because of the internet fractionating everybody. Bill Murray, that's it. Yes, thank you. Yeah, Bill Murray is, like, the prototype of the snark sniper. But yeah. Have I ever seen Taskmaster, a British game show for free on YouTube? No. British game shows. I'm sorry, but the only British game show is, what's it called? 9 out of 10 Cats does, Countdown. Yeah. So it's like, yeah, it's like Gen Z, well, you know, I wouldn't characterize the Zoomer humor as being nihilism so much as Dadaism. go if you don't know what Dadaism is, go look it up. But it's a artistic movement during the 1920s that basically was like, the best thing is for nothing to make any sense at all. It's the elevation of nonsense. But if you were to take the word nonsense and take that word literally, as opposed to like most of the time when people say this is nonsense, they mean I don't like it. But if you take nonsense to mean this makes zero sense intentionally, that's like Zoomer humor as far as I can understand it. But yeah, it's interesting. We live in interesting times. Anyway, I should let you guys go, and if anybody wants to drop by office hours today, I'll be at the university in the afternoon, so see you there, if you decide to come. So, yeah. Take her easy, folks, and don't expose yourself to too much boomer humor, because, pardon me, you might pick up boomerism, and that would just be, that would be terrible. Can you imagine? Ugh. Anyway, take her easy.